So now it gives me great pleasure to call on Professor Jane Hutton of the University of Warwick to talk on mathematics and statistics for effective regulation, comparing the health and finance sectors. Jane.
So thank you, Richard. Thank you to the IMA for inviting me in for the support of Newton Gateway to Maths and the RSS. So what sort of things am I thinking about with regulation? Well, why do we have regulation? Well, there are questions like, did the Royal Bank of Scotland's Global Restructuring Group treat small and medium-sized enterprises fairly after 2008? Does the MMR vaccine cause autism? Is dexamethasone an effective and safe treatment for COVID-19? Is my money safe in the Bank of Utopia? Is the pension scheme adequately funded? Is my information safe? We've all had quite a lot to do with GDPR. So let's look at an example first from the financial sector. Did RBS GRG treat SMEs fairly? Well, the Financial Times about a year ago had a headline saying that the Financial Conduct Authority's report into the disgraced RBS unit had been branded a whitewash. The politician saying the conclusion shows the financial regulator failed to perform its role. And the detailed texts say it's a complete whitewash and they're trying to work out what on earth went wrong. The FCA's response was saying, well, we don't actually have the right powers to do anything. But why did politicians suggest this report was a whitewash? What kind of problems might justify that claim when you've got a report of 78 pages? This is the front page. You can look at the report yourself. What went wrong? What problems would explain that claim of whitewash? Well, basically the data that they chose to look at. So there were 5 allegations, but one of the most important allegations was businesses are assessed for transfer to GRG on the basis of their potential value to GRG and not their level of distress. So this was saying, for example, if I've got 2 businesses, but one of them has got a rather nice bit of property, they're both struggling, I'll try to get hold of the one with the property, foreclose, and then I can sell off the property. So that's a kind of allegation, that was being made. Why were certain businesses supposed to be restructured? And what the report did was it decided to take SME customers, all customers, directly transfer to GRG during the relevant period with debts of 1 to 20 million in the UK. Well, that meant the review was doomed. It was doomed by defining the starting population to include all and only those businesses which had the outcome transferred to GRG, because the review was meant to investigate the reasons for that outcome. If you want to think of it from a health way, consider somebody who says, well, if you drink a bottle of wine a day, you're more likely to have a heart attack. Again, alcohol consumption has gone up during lockdown. Well, if all you do is to take people who have had heart attacks and find out how much they've drunk, you can give us some information about the variation in the amounts drunk by people who have heart attacks, but you can't tell us anything about people who don't have heart attacks. And so you can't actually answer the question. If in fact you do, for example, a cohort study where you follow up lots of people with different levels of alcohol consumption, you can then do something and you find out that in actual fact, alcohol, much to the annoyance of a former general medical officer, is remarkably effective at preventing heart attacks. In fact, all-cause mortality is slightly lower, but cardiovascular conditions are much lower if you drink alcohol. So what else was happening in this FCA report? Having, first of all, not chosen a very sensible starting population, we then have trouble with the description of the SMEs that were selected, a representative sample size. Well, that appears to confuse 2 concepts, power and bias. So by bias, I'm agreeing that we need a representative sample, but that requires a specific approach to random selection. If at the end of term, I ask of 100 students registered on a module for which I'm lecturing, I ask those who are in the lecture theatre if they think my lectures are useful, and there are 50 of them there, I'm not going to get an accurate view. It's not a representative sample of 100 people, because almost certainly the people out there don't think my lectures are useful. So we do have to think quite carefully about what we mean by that, and not just use the most convenient people. Now, the idea of power is having enough people to get accurate conclusions. So, for example, recently in refereeing something, I read a paper about 7 different COVID tests commercially available. And the test of their efficiency in clinical use relied on 13 samples from people with COVID and 6 for people without COVID. And on that basis, they claimed their test was perfect, 100% accuracy for people without COVID. Now, I don't think 6 is a big enough number to estimate 100% from. In fact, it could quite easily have been 5 out of 6 and we'd go down to 83%, very different number. Then we have the other thought that they talked about 4 outcome pools and various other characteristics they wanted to look at. And if you look at all of those, you find you've got 96 subgroups. But interestingly enough, the sample size was 178 small and medium-sized enterprises, which I note is not even double the number of subgroups. But clearly the method of selection wasn't clear, and it clearly wasn't done equally in the subgroups. And then there was another problem. They said, oh, if we find invalid files, we just replace them with similar cases. Well, this requires you to define and judge similar. So let's imagine 2 takeaways that had been pretty successful. Financial crisis has hit, they're struggling. And you've chosen takeaway A to include in your report. But in the spot checks and audits, you've noticed their data quality problems, and you find that with this particular takeaway A, the records of what the assets are incomplete, the books aren't up to date, you haven't got accurate records of what's been coming and going, so you pick up takeaway B instead, which has very well kept books, clear summary of the assets and all the details. Now, that's all very well, but are we sure that there's nothing to do with the ability in bookkeeping and the success of a business? It's quite a big leap. And it's what we as statisticians think about as informative missing data. The fact that the data is not there isn't neutral. It may be telling you rather a lot. So why do we need maths and stats and regulation, and where could they help? Now, I'm not going to go into detail, but for example, pure maths, the security that we all cheerfully assume for our health and financial information relies on encryption. And of course, behind encryption is some very beautiful abstract pure mathematics. It underpins the cryptography, and I'm not going to say anything more because it's not my area. And I'm also not going to suggest that applied maths is only about accurate calculation and reliable algorithms, reliable neural nets or quantum nets, if you like. But one important part of numerical analysis is understanding what makes an algorithm reliable, what means we've got accurate calculations. And actually, I'm going to mention dropping digits and what happens if you do. And with statistics, well, with statistics, we're thinking about collecting, correcting, and understanding data, drawing our conclusions from it. And so I'll mention what happens if you drop patients or measurements. So what happens if you drop digits? Well, thinking about how errors propagate, how errors filter through a system of calculations algorithms is an important aspect of numerical analysis. So, for example, what about the fractions of pennies from interest calculations on your savings or your mortgage? I've heard stories about people diverting these fractions into their own accounts and becoming rich. I haven't bothered to check whether those stories are urban myths or there's any basis for them. But I do know that if you're a 16-year-old, not this year, doing your GCSE exams, you will be expected to keep all digits until you get the final answer. For those of you who watched Chamberlain's lecture last week, he did mention long multiplication, and he mentioned the film Hidden Figures, in which Katherine Johnson had to do a lot of these things by hand, as I did in my youth. It's not so common now. But suppose we've got this question: what's the total cost in pounds of 11 people paid for working 8.3 weeks at 36.3 hours per week and £11.47 per hour? Well, the way a GCSE candidate would be expected to do this, probably on their calculator, would be, if we multiply 11.47 by 36.3, we get 416.361. And you would be expected to keep all those digits and do the rest of the multiplication and get £38,014. If you were doing that and you weren't familiar with your calculator and making notes in between times, and you wrote down 416 instead of 416.361, and then you wrote down 3452 instead of keeping it in decimal places, you would get 37,972, which is out by about 0.1%. However, if you thought, oh no, let's just round as we go along, let's just multiply 11 by 36 by 8 by 11, you would get 34,848. And that is less than 92% of the correct answer. Of course, people who do these sorts of things in their head, as I do occasionally, would quickly not round down three numbers. And so perhaps Katherine Johnson might have used 12 for 11.47. And if you go 12 times 36 times 8 times 11, you get £38,016. So provided you know what you're doing with rounding, it may not be too much of a problem. But I have recently come across accountants from most of the major firms, like PwC, but a cousin who's a senior partner there, and quite an array of actuaries. And I've been amazed that they're not confident when I ask them questions about the cumulative impact of rounding. And also, when you ask how the calculations are done, they just laugh and say, oh, well, people use Excel. All Excel spreadsheets have mistakes, ho, ho, ho. Now, I don't think I actually find that very funny. You know, does rounding matter? So accountants tend to talk about, oh, well, you know, it's not going to make a material difference. Okay, let's think about, say, a local government pension scheme or the railways pension scheme. And it's generous enough that if you retire before you're 65, you get the same benefits as if you retired at age 65. So we're going to need to think about how much does this cost us? So we've got members, we've got 700 women at age 60, 1,000 men, and of those, 230 men have retired before age 61, and just under 200 women have retired. So we can do the calculation and see what the retirement rate is. If you want to check my arithmetic, you can see that was 230 divided by 1,000. That's giving you the 23% there, 28% for women, and so on. Now, what about this both figure? Well, I hope most of the people listening to me will think it's quite difficult to take an average of 28 and 23 and get 30. I wonder where you could have seen something like this. Obviously, we can't take an average between 7 and 13 and get 10, and similarly for some of these other values. But of course, if you're a mathematician, but particularly a statistician, the first thing you do when you see this column, this kind of column, by the way, wasn't in the table I saw, you look at that and you think, so people are only working in multiples of 5. And if you do the calculations, we can see that it's always rounding up to the nearest multiple of 5. So 25.06 has become 30, and so on. Well, what might that do to your estimation of your cost of early retirement if you decided, well, it's far too much effort to think about men and women separately, and it doesn't matter if we round, ho, 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 Excel spreadsheets have mistakes, so never mind. Okay, well, what would the cost of early retirement be, say, in 2010? when the UK life expectancy for a woman aged 60 in 2010 was an additional 26 years to age 86, and for men, it was to age 84, roughly. And again, to keep things very simple, and we're ignoring inflation, women get 15,000, men get 25,000. But if we go to do the calculation for both, we'll just call it 20. Okay, notice our proportions are not equal, so that's not going to be a good average. What would happen? Well, if you work out the total cost using both, that approximation with a bit of rounding, you would get more than $500 million. If you do men and women separately and add it together, you get less than $500,000. The difference is in fact 18%. Is that material? As I say, I've had quite a lot of experience of accountants and actuaries waving their hands and saying, oh, don't worry about the detail, it won't make a material difference. But actually, numerical analysis tells us that if you keep rounding things in the same direction, you're going to get into trouble. It's all very well if you'd use 12 in this figure. If you'd use 12 there, as I said, you'd be okay. But if you round down for all of those, you are very definitely not okay. What about dropping patients? Oops, I've forgotten this has this delightful property of keeping the... Oh no! Am I still visible, Richard?
We can see you, but not your screen, Jane.
Right, sorry, I clicked the wrong button.
Easily done, I'm afraid.
Do you think it's a redial? I'm not sure. Okay, apologies, everybody. I'm just going to see. I can't get this to do something more sensible. No. Ah, okay. Have I reappeared?
Yes, we can see your screen there.
Okay.
So it's dropping patients.
Yes, good. And I have got rid of the green. Okay, good. Sorry. Right. So dropping digits isn't a good idea. That's sort of mathematics. How about getting into some real live examples of health regulation? Well, imagine we've got a randomized controlled trial, which is the gold standard study design for addressing new drugs. But lots of doctors say, well, that's not much use because it's not what we do in practice. We don't see the same things. Your randomized controlled trial reported a 35% success rate. But in our practice, it's much more like 77%. In fact, we've got an open label study where people know what they're on, and we got a success rate of 77%. Great. But that was 77% in the patients they could evaluate, but only half the patients completed the study. So if you actually go back and look at the full analysis in detail, you find the success rate is 40% for the full case analysis. That, by the way, is why we are quite keen in the regulatory world of having properly blinded randomized controlled trials, because initially people would only report on the patients that were successful. That doesn't help all the patients for whom the drugs or the radiation or the other treatment hasn't been successful. And what about dropping measurements? Some people say that above the gold standard randomized controlled trials, we've got meta-analysis pulling all the trials together. Now that's fine, provided a trial gives you an unbiased estimate and p-value. So p-value, well, what I mean by that is that if we imagine a biased coin with a probability that you get a head of 35%, in other words, I'm mocking up the previous slide, and you then threw it 25 times, the probability of getting more than 19 heads, or 77%, is less than 1 in 10,000, or a p-value of 0.01. So that's very different. But what happens if, when I'm actually doing my trial, I don't just have one definition of success, but I've got a whole lot of measurements? And I started thinking about this about 20 years ago, because we were doing a study in which we were looking at urinary incontinence, sorry about the pun with p-values, and there were at least 24 different outcome measures, and most studies used at least 2 measures. That's quite modest in some ways. I think we found 650 different ways of measuring schizophrenia. But what happens if some measurements are not reported and only one is chosen for publication? So imagine that I've chosen the peak flow rate of urine and the total amount of urine and the time to peak flow and so on, but I just choose the results that look to me most interesting. Well, let's think of a simple statistical model for this. We're going to let yk be the maximum of k independent and identically distributed normal random variables. And then we can think about what the probability density function is. The probability density function essentially is going to say, well, I got this maximum value y, but that means the other k minus 1 measurements I took must all have been less than y. That's essentially what this formula is saying. And if we want to look at it in terms of pictures, we can get the standard normal 0, 1. So now I've standardized to a mean of 0, standard deviation or variance of 1. What happens if we take the maximum of 2? So for example, randomized controlled trial of worming drugs given to children in West Africa, and the children's weights were measured, then they're given placebo or the drug, and then 3 months later they were weighed again. And we can either compare the average weight at the end of 3 months between the two groups, or we could compare the change in weight for the two groups. So each child, instead of taking their weight at month 3 after start, we would take the difference in their weight in month 3 after they started. But suppose we'd had several trials, and for each trial we looked at which of those two comparisons gave us a bigger difference. That's what this blue curve would represent. And if we're looking at the maximum of 5, it would be the red. And to give you some sort of feeling about what we mean by that, whereas the unbiased result that we would effectively assume in our results would be centered at 0, taking the maximum of 2 moves us up half standard deviation, maximum of 5 is moving us up 1. And if we wanted to look at p-values, we'd be essentially looking at the area under the curve. And you can see that the area under the black curve above 2 is considerably less than the area under the blue or the red. So I might be concluding that there was a gain of 1 kilogram benefit, say, for the drug, when in fact there was no real gain. And if we're dealing with an expensive drug and you're misunderstanding the benefit of it, you could be doing a fair amount of damage in your economy. Okay, you might say, but surely that's an unreasonable model because those two outcomes are going to be correlated. Children's weights are going to be correlated and the weight gains are going to be correlated. Well, yes, you're right, and you can look at that as well. It's not particularly difficult to write down the model. But even with only 2 trials and 2 outcomes and very correlated outcomes, 0.9, if there was an actual p-value of 0.12, in other words, a 1 in 8 chance of seeing that result, it would be reported as 0.05, 1 in 20. So you get very serious inaccuracy or bias if either patients or measurements are dropped. And in fact, with Paula Williamson, I wrote something about that in 2000, and to her credit, Paula has done a lot of work with many people. And there's now, with most randomized controlled trials, you have to specify what your outcome is going to be. You can't pick your favorite at the end. About the same time, there was a paper published that I was a co-author on about detecting fraud. And one of the most important things you can do to detect fraud is to notice what's not there. Have we dropped digits, patients, or measurements, for example? And of course, can I trust the software that I use to calculate the numbers and draw the graphs? When I started as an academic in 1986, I discovered that if you're a medical statistician, you have to know SAS, because the drug regulation in the US and in Europe required analysis to be done on SAS. Why did they require that? Why couldn't you just write your own programs? Well, because, for example, at that stage, another software, statistical software package with a 4-letter acronym, often got the results wrong. They hadn't made use of numerical analysts and computer scientists to sufficiently check what they're doing. And have you ever tried checking whether something implemented in Excel is correct? Excel, as far as I understand, a programming language is not what I'd call a programming language. And it's not really very easy to check what you've put into it. So what happens in health sector publication and regulation to address these kinds of issues? Well, things have developed a lot over the last 50 years. And for randomized controlled trials and many other major types of studies, you're expected to register in advance your protocol. There's a website, there are two or three websites. What does that mean? Well, it means that if I need to know what studies there are on, say, topiramate, I can go and see what's going on. I can see what studies have been done, obviously since the register started. I can check if a study has ended recruitment and therefore looking out for the publications. And if there are publications, I can check whether they're consistent with the protocol. If they said they're going to assess the effect of an antidepressant drug by using a particular anxiety and depression score, and instead they've decided to report how many people went back to work, I can think, that's rather interesting. Actually, it can be a bit awkward because if, as I did, you get involved in a trial of the best treatment for sprained ankles and nobody agrees how to measure improvement in sprained ankles, how do you choose what your final outcome is going to be? But anyway, so you've got all this information registered, and then I said, check if your publications are consistent with the protocol. Well, you can only do that, of course, if the publication gives you sufficient information. And that's why something has developed called the Equator Network, enhancing the quality of research in treatments. Those guidelines have been developed and checklists. And what these do is let you know how best to assess the accuracy and the relevance of a study result. You can go and look at those yourself if you like on the network. I'm going to give you a little illustration of the example of the kinds of things that have happened. So Friday last week, there's a preliminary report of a randomized controlled trial. You can see that it had a registered number. And so they stated in advance what they were going to do. And they're reporting on, I'm going to call it DEXA, in patients with COVID. If you look at the abstract of that URL, you'll find just over 2,000 patients assigned to receive DEXA, 4,300 assigned to receive usual care, and the percentage of deaths within 28 days, 22.9% on DEXA, 25.7% on usual care. Actually, it's quite interesting, but I'm not going to go through it all. What I want you to notice is these numbers. That's about 6,500. Yes, I do rounding. But here is one of the things that's now required when you report a randomized controlled trial. You have to produce a flowchart of patients. I'm not quite sure what the size is, but the original number of patients recruited was 11,300, right? Quite a lot more than 6,500. And we find that nearly 2,000 were excluded. Could have been for more than one reason. For 3%, it's because the drug wasn't available. And another 15%, despite having been recruited, were then considered unsuitable for DEXA. Now, this kind of information is quite useful if you work at sort of public health or government level, because if you're trying to plan and you have a set of criteria by which you're going to be getting the numbers of people, and you then find those criteria perhaps aren't that good at screening, well, you can start thinking, do I change the criteria? What else do I do? Okay, but that's legitimate. They were excluded. Then we randomized 83% of patients to DEXA and other treatments. And in fact, nearly 3,000 were assigned to receive other active treatment. So another article by the team that did this work might report on that, but for the moment they just disappear off to the right. And we now have 57% of our original patients are randomized between DEXA and usual care. And we think, good, phew, we've managed that. Well, yes, but and notice this is a roughly 2-to-1 randomization, which suggests to me, without having read it in detail, that people were a bit worried that DEXA might have quite bad adverse effects. But of those people assigned to DEXA, 95% of them received it. And of those assigned to usual care, well, 8% actually got DEXA. And then you can see some people withdrew and other people proceeded to second randomization, and so the flowchart goes on. But looking again at what's happened, we now have a choice. We can either analyze the results as patients were randomized, as intention to treat, or we could say, well, actually, we'll move the people who didn't get DEXA, but got the rest of the care, off to the other group, and we'll move the DEXA group back. And in fact, you would normally be expected to look at both of those and think of the sensitivity analyses. That actually gives you a bit of a feeling of what happens in health sector regulation. The checklists will provide you with a good indication of the approach. If you want a brief overview, the guidelines and the articles give you more information. But essentially what is required before a study begins is what data you're going to collect. How are you going to collect it? We've heard about obesity and COVID, but how did we decide on obesity? Was it a clinician looking at somebody and looking at me and saying, you're overweight, Jane, you're borderline obese? Did somebody ask me my height and weight? Did somebody measure my height and weight, or perhaps my length if I'm lying on a bed, having difficulty breathing? What was done? When was it done? How often are we collecting data? And why are we collecting it? One of my pet hates is that people always try to collect lots of data, with the net result that lots of the data is missing. Now, in clinical trials, you have interim checks on quality and safety, and the who there is that is usually done by an independent group, so that when, for example, there's a trial of probiotics in intensive care, and they turned out, rather than improving health, they turned out to be quite good at killing people, you do tend to want to find that kind of thing out early on. You also, in advance, are expected to specify results. What methods will you use? What summary tables? What models? What software will you use? And though you're not allowed to just write something on Excel. And what are you going to do about missing data and protocol deviations? So when you then produce a report, you have to explain your protocol deviations and explore them. Like the example I gave from that trial on the previous page, explaining why some people got DEXA who shouldn't and some didn't who should, and how much difference does it make. If you're then wanting to get your drug taken up by mice, except for COVID, where the rules are sort of torn up, you're essentially going to be saying this drug buys this amount of life at this quality. To do that, you have to submit your economic models with explicit assumptions, and indeed you have to give the software to the committee so they can run it and they can check your assumptions. How does that work in other areas? What are the standards like elsewhere? Well, in my experience, when I asked for basic information, I was simply refused it. There's a very well-known international consulting company that was doing something on salaries. And I said, that's a rather odd assumption. What happens if you vary that assumption? And I got another set of, would you believe, PowerPoint slides. What kind of organization produces technical information in a PowerPoint slide? So I then said, look, I can back calculate what you're doing. There's a discrepancy of 17%. Precisely what have you done? And the email came back, dear Professor Hutton, this is one of our more complicated spreadsheets. We might have to give you the spreadsheet or even the mathematical formulae. Shock horror. Well, I replied, well, if you gave me the spreadsheet, I could tell you what formula you've implemented, but what you should be giving me is the formulae, the implementation, and a detailed explanation of how you check that the documentation was correct. So in the medical world, the MMR vaccine and autism, you could use the checklist called STROBE, which tells you what to do with observational studies and surveys. If I apply the same standard of that to the Financial Conduct Authority's review of the RBS GRG treatment of SMEs, that report basically is a thoroughgoing failure. Whereas the DEXA example I've given you, I've shown you enough that you should believe me when I say they've clearly worked really hard to be very accurate and tell you everything that went wrong as well as right. But if you ask people whether the Bank of Utopia is safe, whether your pension fund is accurately done, you're going to be faced with stuff done with Excel spreadsheets presented in PowerPoint, laughter when you ask about accuracy or communication or trust. Baroness Honora O'Neill has made some very useful remarks on intelligent transparency and trust. That's what we need for regulators, and that's what I'm looking forward to discussing in detail on the 17th of November with a wide range of people from different sectors, from the civil service, regulators, mathematicians, industry, and so on. But for now, thank you for attending this talk.
Thank you. On behalf of the audience, I'd like to thank you for your presentation. And now we have the opportunity to ask some questions. I'm going to, now you can see me ask you the questions. That's, in the chat box, Q&A box, there is a question from Tim Coffey. Would it, about rounding, he asks, would it be advisable in the rounding example to round weekly wage to the penny, fractional week's pay to the penny, and then multiply by the number of people?
I mean, the point is always that the basic rule is that if you could keep all the digits, you keep them all the way and you only round at the final stage. You know, yes, I'm sure my numerical analysis and computer science colleagues can tell me about the finer points of double precision arithmetic. What I was really drawing on was the contrast between the idea of the level of accuracy expected of a 16-year-old and my experience of major players in the financial sector who completely disregard that, who don't think they need to live up to the standards of 16-year-olds, and regulators who also don't think that banks need to live up to the standards that 16-year-olds are expected to adopt.
Thank you. Tim comments that the reason he asked that particular question was that was how a salary would be paid. Oh
yeah. I mean, you know, clearly I just invented an example. Once you're actually in a specific context, so it really becomes important to think of the details and the trade-offs.
So that does raise an interesting point in terms, I think, of what some people call the metaphor, which is that people want to see their calculations done in a way that reflects their experience and their understanding. Do you think that that's a common phenomenon, that people are given information in the way they expect to see it?
There've been quite a lot of development. So if you go back to the medical world, if you go back about 25, 30 years ago and you were screened for breast cancer, the leaflets, patient information leaflets, wouldn't mention the fact that there are such things as false positives or false negatives. Whereas now, you know, Professor David Spiegelhalter has done a lot of work on this. Now there's a lot more effort with patients. The other big difference is in the health sector. If you're doing research, you have to have patient and public involvement. Whereas the pension regulator is busy doing the opposite and trying to drive out any member trustees or employer trustees in favor of so-called professional trustees. In other words, people who have no interest, no skin in the game, have nothing to lose if the contribution rates are excessive. So it's, you know, it's interesting comparing the sectors and seeing them going in opposite directions.
You made make an interesting comparison there between the medical sector and the financial sector. I see that in the Q&A box, an anonymous attendee, that is their name, asks, quotes, regulation standards differ widely, and goes on to ask whether that's also true within the medical sphere, in other words, in terms of treatment of diseases. Is there a sort of regulatory arbitrage there?
The basic standards are agreed, and there's quite a lot of effort translating those from drug treatments across to devices. There have to be some differences. I mean, there was a drug for children that caused a very serious problem, a new drug, and so you can immediately put out a notice saying transfer all your patients back onto the old drug. On the other hand, if you've got a problem with a pacemaker, it's an awful lot more difficult to suddenly say, whip everybody's pacemakers out. Surgery itself has risks. So I think they are, if you like, intelligently consistent. Yes, you do get modifications. If you've got a very rare disease, you simply have to accept there's much less information. But usually the preference is that more money and wider collaboration is done to get more patients, rather than just giving up and concluding on the basis of 6 people you've got 100% success rate. But yeah, I think the other thing that I'm aware of in the healthcare sector is you have a wide range of disciplines and you have lay people, and they will disagree, and that's very healthy. I will see something one way because of my experience, and somebody else will come in and say, but you haven't come across this, or you don't know that. And I think, again, the health sector, the medical medicines and devices sector, has matured a lot in the sense of trying to work hard at listening to a range of professionals and a range of people who are affected by the decisions. So whereas one painkiller was taken off the market because of risks associated with it, another drug that has very side effects is still on the market because now people are given the option of deciding the balance of risk and benefit for themselves.
That's very interesting. I'll take the opportunity, if I may, to ask a question on my own account. One of my interests is in the professional side of the IMA. Do you think that mathematicians as a profession are we sufficiently engaged and active in these regulatory areas, or are we standing back too much from the heat of battle?
Well, I can't speak for the London Math Society and the IMA. The RSS is working quite hard, and certainly individually I'm working quite hard to see what the all-party parliamentary group and whistleblowing is doing and see what can be done to cross-fertilise between different sectors of regulation. I'm sure that people who are experts in the financial side would come and complain roundly about the health sector aspects of regulation, but from my point of view, I would be happy to see people from mathematics who are aware of accuracy of algorithms, how you test the reliability of software, and accuracy of calculations, taking a bit more interest in some of what's happening in accountancy and financial mathematics and insurance, pensions, and so on. I suspect they could probably contribute some improvements.
So following on from that, Caroline Series asked the question, we've been talking effectively in terms of what happens within the UK, and she asks, to what extent are the conventions for regulation, medical regulation, international, and do you expect that Brexit will make any difference to those international connections?
Right. So my understanding is that, I'm going to answer the question in reverse. My understanding is that the actuarial profession on the continent is much more advanced. You actually have to be a competent mathematician to enter the profession, which is not a requirement in this country, apparently. But in terms of medicines, there are slight differences, but essentially because unless you're treating a very rare condition that only happens in your country, you're going to want to develop things internationally. So the standards are more or less harmonized. And if you've got a drug approved in Europe, you do actually have to run a trial in North America before it'll be approved in North America, as far as I understand. But the kinds of things you have to do won't be radically different. So yes, the standards are pretty much international.
The testing protocols and procedures would be effectively the same the world over.
Yeah, on paper. Obviously, reality and paper aren't always the same. But yes. I mean, so for example, a colleague of mine in Cape Town who ran a trial, HIV and a cardiac problem. Yeah, that's run at exactly the same kind of standard as you would run it elsewhere.
We do, I suppose, at least have the advantage that the laws of arithmetic are the same internationally, and I'm not expecting them to change at the end.
Yes.
If members of the audience have more questions which they haven't yet typed into the Q&A box, I'll remind them that they have the opportunity to not only ask those questions in more detail, but indeed to take part in the one-day workshop, which is taking place on, it's in the chat box, here we are, the 17th of November, Tuesday the 17th of November, hopefully at the Royal Statistical Society headquarters in London, and the link to that is at the Newton Gateway website. So I think now, with time nearly on us, all that remains for me is to thank all today's speakers, but especially Professor Hutton, for giving us a view of a wide range of very interesting and very much up-to-date and timely applications of mathematics. So thank you to all our speakers.